Hi learners, in this video we are going to see how the image is converted into a digital image and what are the process is going to be there when converting into a digital image. Before entering into this part, just we can recall this digital image processing, definition of digital image processing. So what is digital image processing? Digital image processing is just a two-dimensional functions, or we can say that it is an array. So we can convert an image into a two-dimensional array and then we can go for processing. So the xy value is said to be a spatial coordinate of digital image, and the values of xy is a that is, we can call that it as a amplitude or intensity values or gray level values, whatever it is at that particular point x comma y. And then in processing this digital image, we can call that as a digital image processing. So this categorizing this processing image, we can go for three levels. One is low level, middle level and high level. And then in this low level, we are going to enhance the image. So according to the application, the enhancement, there are many various methods for enhancing the images. So here, according to the application, we have to select the enhancement technique. So here in low level, many primitive operations are going on in enhancing the images. That is reducing the noise, enhancing the contrast, or sharpening the edges, and smoothening the edges, or many methods are available. So here the input for this processing is an image. That is, we can give the image as an input, and after processing we are getting the output as also an image. And next level is middle level. So in this middle level, that is the output of this low level is an input for this middle level. So here, when getting this digital image after enhancement, so this middle level segmenting the image, that is, it extracts either the edges of the image or some of the object in the image, or otherwise some attributes, that is the data of the images. So extracting something from the image is said to be a middle level. And next level, in this middle level, that is the input is output of low level, that is the digital image, and the output of this middle level, it may be an attributes, that is data or edges of the image or object. So the output may be an image or may be a data. So next level is a high level. So in this high level, we are giving the input of this high level processing is the output of middle level. So after getting that output of middle level, just analyzing this input, that is the output of middle level, and then recognize that what is the things we need, analyzing the data of the image and give the output according to the application. So this three level is the basic categorize of this image process. That is low level, enhancing the image, and then middle level, segmenting the image, and high level, analyzing the image. So these three levels are in the digital image processing. And now we see how the image is converted into a digital image. So here, when you are so here this is a light source and this is an object. So here, when the light source hits on the object, this object reflects that light source. So the source, this is a light source. So when capturing the image, so there is a, when we are having a powerful light, when we are capturing the image under the powerful light, we are getting a more clarity in the image. So this depends on this light source and also the reflection of the source, reflection of this energy, we are getting the quality of the images. So this illumination energy and reflection energy gives the quality of the image. So the image depends on this illumination and then reflections. So this is captured by the image system, in the analog form, and then we are converting into a digital form. So here this is I of x comma y is said to be an this x comma y is said to be an elimination, and r of x comma y is said to be an reflection of that sources by the object. So this this both gives the intensity value of that image. So here this eliminations range from 0 to infinity, and the r of x comma y that is ranging from 0 to 1. So converting the image into a digital form, so we have to go for two processes, that is, one is sampling, another one is a quantization. Sampling, that is, we can represent the image as a two-dimensional array. So sampling is deciding number of rows and columns in the image. So we can say that how many rows and columns we need when digitizing the images. So that process is said to be a sampling. And what is the value that we have to store in that particular array? So we can call that as a quantization. So for example, so here this is an analog image, that is the image which we captured, and here when you are say about this part here, so this is here number of rows and column. So this number of rows and column is sampling, deciding the number of rows and columns is sampling. And here when you are seeing this part, so here this is very in this box the value is very small, the shade is very small, so we are ignoring the value. So if it is somewhat if it has a more than quarter, then we can fill the entire pixel value. So here this part, so this part we are filling the entire pixel value, and here for this part this is a very small amount in this pixel, so we are ignoring this. And similarly, so here this part we are considering this part. So similarly this part is very small, so we are ignoring this. So here this converting that into a digital form, we have to decide the value, what value that we have to store in this xy part. So this is said to be in quantization. What value we have to store in the xy. So what gray shade should be there, that has to be defined in the quantization process. So representing the digital image, so we can represent this as a two-dimensional, just like a two-dimensional array. So 0, 0 and m minus 1, n minus 1. So m and n is the number of rows and number of columns. That is width of the image and height of the image. So that is m into n. So starting from 0, 0, end with m minus 1, n minus 1. So the deciding this m and n is said to be in sampling, and the value of this each part is said to be in quantization. This is one way of representing the image, and also this is another way of representing the image. In this way also we can represent the image, that is a 0, 0, 0, 1, and this way also. And now we have to go for how we have to calculate the number of bits required for storing the image. So m into n. So m is the width of the image, n is the height of the image, and the value that we are storing for each pixel, k is the number of bits required for storing the each bit. So here when you are taking this, so this is f0, 0. So how many bits we need to store the value of 0, 0? So that is a k. So total number of bits width into height and number of bits required to store each value. So totally B. So here in this example, that is 32, that is row and column are both same here, that is width and height. So that is width is 32, height is 32, and here we are having required bit is 1. So if it is bit, there is a 1 bit, then we can store two values there, either 0 or 1. It is either black color or white color. So we can go for storing a true value. So this is a binary image. So for binary image, we need only 1 bit for storing a value of that image. So here 32 into 32 and 1. So totally we need 1024 bits for storing a binary image which has a width 32 and height 32. If there is a 2 bit for storing a single pixel value, and then we can store 4 values there. That is 4 intensity value we can store in each bit, either 0, 1, 2 or 3. So we can store 4 values. So totally we can get a 32 into 32 into 2, 2048. So similarly we can calculate the number of bits that we need to store a image which has a m bit and n height. Now I am going to explain how to process this image. So here image 1 is my input image. Just I am getting the bit. So this is using Java. Just have implemented the image, that is process the image. So here this image 1 is my input image. I am getting the width of the image and height of the image, and then I am getting the value. So width up to width and height, just I am taking the value of each pixel by image word get RGB x comma y. So this I stored in the color class. So the pixel value, that RGB value stored in x comma y is converted into a color class. So using this color class C1, just I am taking the red, green and blue separately and add this 3 value and getting the average of this this 3 colors, and then I make that as a new color and set it in my output image. So this is my input image and this is my output image. So just I convert this original image into a gray image just by getting the red, green, blue separately and then finding the average of this and then put it in my output image. That's all. So using the applet, just I did this processing. Just to show the output. Okay. So here just I am selecting the image and this is my input image. Just by clicking this, converted into a gray image. So here just I am getting the red, green, blue of each pixel and then getting the average. Suppose here for getting the negative image, just the maximum value for the gray image is that white is the maximum. So the value of white is 255. Then I subtract the value from 255, then maximum value. Now see the output. So this is black and white image. So this is the original image and this is the black and white image. Now see the output. Just I am selecting the same image. Now you can see the negative image. So that's all. Just getting the value of just getting the red, green, blue, the value of this RGB, and finding the average, and when we display this average value, and we can get a gray image. And then if we are subtracted from the maximum value, that is 255 is the maximum value, subtracted that value from 255, we will get a negative image. So in each way, just in enhancement processing, we can convert that original image into a two-dimensional function, and then we can process the each pixel value, and we can go for enhancing the image. And many methods are available for enhancing the image. So according to the application, we can select the methods. In this video, we'll see how the image is converted into a digital image, what are the processes were going on when converting the image to process sampling and quantization, and also how to convert that digital image into a two-dimensional function, and how we have to process the image in the two-dimensional functions. So using the simple for loop, we can process the images, enhance the images. Thank you.